Today we have a special guest on the Data Professor YouTube channel. His name is Joachim Schork, and he is a statistician, programmer, and SEO expert from Germany. Joachim runs a YouTube channel and blog website called the Statistics Globe, where he teaches about R programming as well as statistical tutorials. So links to those websites and YouTube channel is provided in the video description. And today in this video, Joachim will be talking about how you can handle missing data in R. And so without further ado, we're starting right now.
Thanks a lot for the introduction, and also thanks a lot for providing me the possibility to speak on your channel today. So in this video, I will discuss how to deal with missing values using the R programming language. And in this video, I will speak about different topics that you can see on the side of this video. So first, we will create some example data that contains missing values, and we will use this data in the examples of this tutorial later on. Then in the next step, I will apply Listwise Deletion to our data frame, and I will discuss the pros and cons of this method. Afterwards, I will use a missing data imputation to impute our missing values with new values. And then last but not least, I will apply a multiple imputation to impute our values multiple times, and I will explain the advantages of multiple imputation compared to single imputation. So as I have mentioned before, the first step of this tutorial will be the creation of some example data with missing values. And the creation of this data set starts in line 6 of the code. So in this line of code, we are first specifying the number of cases that our data will contain. So in this case, we will create a data set with 5,000 cases. So if you run line 6 of the code, a new data object appears at the top right of RStudio, which specifies the number of cases in our data. In the creation process of this data frame, we will also sample from random distributions, and for that reason it also makes a lot of sense to set a random seed to provide reproducibility of our code, and we can do that by running line 7 of the code. So after running this line of code, you will be able to create exactly the same data as I do in this tutorial. In lines 9 to 11, I'm creating some predictor variables that are called x1 and x2 and x3. So if you run these lines of code, you can see that 3 new vector objects appear at the top right of RStudio, which are called x1, x2 and x3. And as you can see in the code, these variables are related to each other, or in other words, there is a correlation between these variables. In the next step, in line 13 of the code, I'm creating a target variable, which is called y. And this variable is also based on the other predictor variables x1, x2, and x3. And then we are also adding some random noise to this variable. So if you run line 13 of the code, another data object, which is called y, is appearing at the top right. And then I'm duplicating this variable in a new data object, which is called yTrue, because in the next step, in lines 16 and 17 of the code, I'm inserting NA values into our data. So in line 16 of the code, I'm using a random process to create NA values in our target variable y. And as you can see, the probability to be NA in the variable y is based on the variables x1, x2, and x3. We will analyze that later on. So if you run line 16 of the code, our y variable is updated, and now the variable contains NA values. And if you run line 17 of the code, we will also insert NA values into the predictor variable x2. Finally, we are storing all the variables that we have just created in a data frame, which is called data, and we can do that by running line 19 of the code. So after running this line of code, a new data set appears at the top right of RStudio, which is called data. And if you click on this data frame, you can see that a new window is opened, which is showing the structure of our example data frame. And as you can see, our data frame contains 4 variables. The first variable is called y, and this is our target variable. And then we have 3 predictor variables, which are called x1, x2, and x3. And as you can see, the variables y and x2 contain missing values, but the variables x1 and x3 are complete So these variables do not contain any missing values. As last step of the data creation process, I'm removing everything but our data frame and the true y variable without missing values. So if you run line 21 of the code, you can see at the top right of RStudio that our environment is cleared. So at this point, we have only our data frame and the true y variable left in our environment. So in the next step of this tutorial, I want to show you how the structure of our data looks like in some more detail, or more precisely, how the missing values in our data frame are distributed. And for that, we are using the ggplot2 package because I want to show you how the missing values are distributed in our example data frame. So in order to use the functions of the ggplot2 package, we need to install and load the package, as you can see in lines 27 and 28 of the code. I have installed this package already, so for that reason I'm just going to load it with line 28. And after running this line of code, we are able to use the functions of the ggplot2 package to create plots based on these functions. In order to analyze our missing values, I'm also going to modify our data frame. So in line 30 of the code, I'm adding the true values that we have stored from the beginning of the data creation process to our data frame. And in line 31, I am also adding another variable to our data frame, which identifies rows with missing cases in the variable y and rows with observed cases in the variable y. So if you run lines 30 and 31, a new data frame, which is called data true, is created at the top right of RStudio. And if you click on this data frame, you can see that we have created two new variables in our data set, which are called yTrue and missings. And the variable yTrue will be used as benchmark later on, because the values stored in this variable are the true values that we have deleted from our vector. Of course, we would not have these data in a real-life example, but since we have created the data set ourselves, we know how the true distribution looks like, and for that reason we can compare the missing data methods that I will use later on in the examples later on to the true values in our variable yTrue. So in the next step of this tutorial, I'm going to visualize our missing data based on the data set that we have just created. So in lines 33 to 39, I'm creating a scatter plot in which I'm showing the missing values and the observed values of our data. So if you run these lines of code, you can see at the bottom right of RStudio that a new scatter plot is created. And in green points, you can see the observed values. So these would be the values that we have in a real-life example. And the red values show the points that are missing in our variable yTrue, and these points would not be available in a real-life example. However, since we have made up the data ourselves, we can see the structure of the missing values. And as you can see in our case, the missing values are heavily shifted to the right side of the plot. So in other words, the larger the values are in x2, the more likely it is that they are missing. And since the variable x1 is correlated with the variable yTrue, as you can see in this scatter plot, the lower values of y are also more likely to be missing. And this of course has an impact on the analysis of our data. So let's assume we would like to measure the mean value of our target variable y. Then we could apply the mean function, as you can see in line 41 of the code. So in this line of code, I'm measuring the mean value of our observed values, so of the values that you could measure in a real-life example. So if you run line 41 of the code, you can see that we would estimate a mean of 0.0017. However, if you measure the mean value of our true values, as you can see by running line 42 of the code, the true mean value is minus 0.337. So in other words, if we would just use the observed values to measure the mean of our target variable y, we would heavily overestimate the mean value. Or in other words, our analysis would be heavily biased. So for that reason, it is very important to handle our missing values properly to reduce this bias as much as we can. And in the following examples, I will show you 3 different methods on how to deal with our missing values. And you will see that each of these methods leads to different results. So let's move on with the first example of this tutorial. And in this first example, I'm going to apply listwise deletion, as you can see, starting in line 45 of the code. So in line 48 of the code, I'm using the na.omit function to apply listwise deletion to our data. And as you can see, listwise deletion can be applied very easily because we simply need to specify the name of our data set within the na.omit function. And in this case, we are also storing the output of the na.omit function in a new data frame object, which is called data listwise. So if you run line 48 of the code, you can see that another data frame appears at the top right of RStudio, which is called data listwise. And if you click on this data set, you can see the structure of our new data frame. And as you can see, this data set is complete. So we have removed all missing values from our data set. However, you can also see that some of the rows have been removed entirely. So for instance, the row number 1, 2, and 3 are removed entirely from our data set. And you can see why this has happened by clicking on the real data set that we have created in the beginning. So here you can see that the first 3 rows contain missing values. And you can also see that the listwise deletion method does not only delete values that are missing in our target variable y, it also deletes rows that have a missing value in a predictor variable. So for instance, the row number 3 has a missing value in the predictor variable x2, but not in the target variable y. And still, if you click on our listwise deletion dataset, the row number 3 has been removed from our dataset. So in other words, the listwise deletion is deleting many rows from our dataset, even when the target variable contains a valid value. So depending on the number of variables in your dataset and depending on the percentage of missing values in your dataset, your final output of the listwise deletion method will contain much fewer rows than your input dataset. And this is of course a problem because if the missing values in your data are not randomly distributed, your results will be biased. So you can see that in this example by comparing the mean value of our listwise deletion dataset with the true value. So if you run line 50 of the code, you can see that our mean value returned by the listwise deletion is 0.013. However, the true value, as you can see by running line 51 of the code, is minus 0.337. So the difference between the result of the listwise deletion compared to the true value is relatively large. And in this example, you can see that the mean value would be estimated even to be positive when we use listwise deletion, even though it is negative in our true values. So as you have seen in this first example, listwise deletion can lead to heavy bias in your data in case the missing values are not randomly distributed. And for that reason, I want to show you other methods which can be used to reduce the bias that results from missing values. And the first method that I want to show you is called single imputation. And the application of this method starts in line 54 of the code. And in order to apply single imputation to our data, we first need to install and load the mice package, as you can see in lines 57 and 58 of the code. I have installed this package as well, so for that reason I'm just going to load it with line 58 of the code. And after running this line of code, we are able to use the functions of the mice package, such as the mice function and the complete function that you can see in line 60 of the code. So in this line of code, I'm applying the mice function to our data set, and then I'm also specifying the m argument to be equal to 1. And if we specify the m argument to be equal to 1, we use a single imputation. And then I'm converting the output of the mice function to a complete data set by using the complete function. So if you run this line of code, a new data set is created, which is called data single. And you can also see at the bottom in the RStudio console some information about the imputation process, because this output shows the number of iterations that have been used to impute our variables. Then it shows the number of times our data has been imputed. So in this case, only one time because we have used single imputation. And it also shows the variables that have been imputed. So as you can see, we have not only imputed our target variable y, but we have also imputed the missing values in the variable x2. You can also see that by clicking on our new dataset, data single, at the top right of RStudio. And as you can see, this new dataset is also complete. So there are no missing values in our data anymore. However, you can see this time we have not removed any of the rows because we have replaced the missing values by new values. So for instance, the value in the first cell of our target variable y has been replaced by minus 0.141. And as you can see in the original data set, this value has been missing. The same for the second value in the variable y, or for instance, the third value in the predictor variable x2. So as you can see, all of these missing values have been replaced by real values, and the values that have been inserted instead of the missing values are based on a statistical model. So in other words, they are approximating the values in our true data as good as possible. So we can now use this new data set to calculate the mean value of our target variable. So as you can see in line 62 of the code, we are using our new imputed data set to calculate the mean value. So by running line 62 of the code, you can see at the bottom that the mean value of our imputed data set is estimated to be minus 0.30. And as you might remember, the mean value of our true values is minus 0.337. So in other words, we are now much closer to the true value as in the listwise deletion example, because as you might remember in the listwise deletion example, our mean value was estimated to be even positive. So as you have seen in the single imputation example, we were able to reduce our bias in the mean value estimate heavily, which is already a very big advantage to methods such as listwise deletion. However, the single imputation method has one big problem, and that is that we are just assuming that we have a real data set when we are imputing data, and we are not taking the uncertainty of the missing data imputation into account when calculating variance estimates or when calculating confidence intervals. So I think it goes beyond the topic of this video to explain variance estimation and confidence interval estimation at this point. However, I will put a link into the description of the video where you can read more about confidence interval estimation and about variance estimation and about the drawbacks of single imputation when estimating the variance. However, what you can remember at this point is that single imputation is able to reduce the bias of an estimate. However, it also underestimates the variance of this point estimate, and for that reason we need another method which takes the uncertainty of the imputation process into account. And in order to take the uncertainty into account, we can use multiple imputation instead of single imputation, and this is what I want to show you in the last example of this tutorial. And in order to apply multiple imputation, we can also use the functions of the mice package that we have already loaded before. So for that reason, I don't need to load it again at this point. So as you can see in lines 69 to 71 of the code, I'm again using the mice function and the complete function. However, this time I'm specifying the m argument to be equal to 5. So this tells R that our data should be imputed 5 times. And then I'm also setting the action argument of the complete function to be equal to broad. And I want to include my missing values also to the final data set. So if you run lines 69 to 71 of the code, you can see that some other output is created at the bottom in the RStudio console. And as you can see, this time we have used 5 iterations. Then we have imputed our data 5 times. And again, we have imputed the variables y and x2. So after running lines 69 to 71 of the code, you can see that another dataset appears at the top right of RStudio, which is called data multiple. And if you click on this dataset, you can see that we have created a huge output which contains every variable of our input dataset 6 times. So at the beginning of the dataset, it contains the original data. This is because we have specified the include argument to be equal to true. And then at the later positions, it contains 5 versions of our imputed data. So the variable y, our target variable, is contained 5 additional times in this dataset. Admittedly, this makes the data more complex. However, as I have mentioned before, this allows you to calculate the variance of your point estimates more properly. So if we now want to calculate the mean of our multiply imputed dataset, then we have to calculate the mean of each of our imputed target variables separately, as you can see in lines 73 to 77 of the code. So in these lines of code, I'm creating a vector which is containing the mean of the variable y1, the mean of the variable y2, the mean of the third imputation, the fourth imputation, and the fifth imputation. So if you run lines 73 to 77 of the code, you can see that a new data object appears at the top right, which is called mean multiple. And we can have a look at this data object by executing the name of the data object. And then you can see at the bottom in the RStudio console that we have calculated a vector consisting of 5 mean values. And as you can see, the mean values of each imputation are different. So for instance, the mean of the first imputation is minus 0.30 and the mean of the second imputation is minus 0.277. As you can see, all of these mean values are much closer to the true value than the mean value based on the listwise deletion dataset. So this again shows the disadvantage of listwise deletion and the advantage of missing data imputation. However, you can also see that there is a variance between the mean values. And this is the advantage of multiple imputation compared to single imputation, because multiple imputation takes this variance between the imputations into account. And for that reason, we can calculate the confidence intervals and the variance of our point estimates more properly. However, at this point, we are interested in the mean value, so only in the point estimate, and we can calculate the final mean value of our multiply imputed dataset by running line 79 of the code. And in this line, I'm calculating the mean of our 5 mean values. So if you run line 79 of the code, you can see that the final point estimate would be minus 0.295. And again, if you compare that to the true value by running line 80 of the code, you can see that we are relatively close to the true value, and for sure much closer to the true value than based on the listwise deletion. So in this video, I have explained some methods on how to deal with missing values using the R programming language. I hope I was able to show you the disadvantages of listwise deletion and the advantages of missing data imputation, specifically multiple imputation. In case you want to learn more about topics like that, you could check out my homepage statisticsglobe.com and my YouTube channel called Statistics Globe. Thanks again to the data professor for providing me this possibility to speak on his channel, and thanks a lot for watching. See you next time.
And I hope that you found this video helpful, and please don't forget to check out Joachim Schork's website, and the links will be provided in the video description. And if you're finding value in this video, please give the thumbs up, subscribe if you haven't already, and make sure to hit on the notification bell so that you'll be notified of the next video. And as always, the best way to learn data science is to do data science, and please enjoy the journey.